For part one of Le Chatelier's principle, you're going to need the bottle of potassium thiocyanate, and you're going to need your dropper bottles that also have potassium thiocyanate and your iron nitrate. You'll have 6 test tubes. Please label them 1 through 6. It's best if you are writing on the frosted area, which is blue in these test tubes, that you use a pencil so that it can easily be erased. If you do not have a frosted area or you do not have a pencil, you can use a Sharpie on the glass part. You're going to need a cold water bath and a hot water bath for this experiment as well. You begin by measuring out your 50 milliliters of the potassium thiocyanate solution into a small beaker. Now remember, you're going to use your smaller beakers for your hot water bath and cold water bath so the test tubes don't tip over in here. So try to avoid using your large test tubes for this go around. You're going to add 4 drops of your iron solution to the potassium thiocyanate. And you'll start to notice an orange or even reddish color appearing. You want to use your stirring rod to blend this throughout. It will lighten in color. And this is your equilibrium mixture. You're going to distribute this mixture between the 6 test tubes, and it's fine to have a little bit left over. You're going to have approximately 8 milliliters, or right up about to where the frosted label is. Remember that the idea of Le Chatelier's principle is that when we have a system that's at equilibrium and we disturb it in some way, the system is going to react to restore equilibrium. So it's going to shift back in whatever direction is going to get it to equilibrium. So we can do this in a variety of ways. We can do this with energy by hot and cold water baths, raising and lowering the temperature, but we can also add either reactants or products, or we can take away reactants or products. So each of these different mixtures is designed to see how one of those things will work. So go ahead and take your test tubes 5 and 6 and place them in the hot and cold water bath so that they can start shifting towards their equilibrium. You want them in those baths for at least 5 minutes. A little longer isn't going to hurt them. Now remember, your first test tube is going to be your reference. So you'll pull that out and kind of compare each test tube to this one to see how it is shifted. Now let's take a look at the second test tube. You're going to add 2 drops of the KCN solution, potassium thiocyanate solution. And this is much more concentrated than your original potassium thiocyanate, so you don't want to use what's in the bottle, you want to use what's in the dropper. And when you pull it out, you may see that the reaction is mostly near the top, so you want to use your stirring rod to make sure that that's well distributed. Now we can compare the first 2 to see any differences we might notice. Into the third test tube, we are going to add 2 drops of the iron. In the third test tube, we're going to add 2 drops of the iron solution. Now we added 4 drops before, but it was to all 50 milliliters. This is to a much smaller portion, so it should have a much stronger effect. So I'm just going to add 2 drops here. And I should see a little bit of a reaction going on. And again, I'm going to want to use a clean stirring rod to stir that mixture. So in this case, we have added one of either the reactants or the products. Now we want to try and take away one of our products. And so when we add the when we add the sodium fluoride, the fluoride will react with the iron and remove it from solution. So as we remove the iron, we're going to shift in the direction that is going to help to replace that iron ion. Your directions say to use a pinch. You're going to use a micro spatula and just put a tiny amount on the end of the spatula and put that directly into the test tube. And once again, use a clean stirring rod to make sure that you have thoroughly stirred what's in that test tube. Then, going back each in turn, compare your test tubes to the first test tube so you can see how they've changed. At this point, you can also compare your hot and cold samples. You can compare them to each other, and you can compare each of them in turn to the original equilibrium mixture. Okay, when you are ready to do your colorimeter readings, you are going to turn on graphical analysis and open up your sensor connection and check the ID number of your colorimeter and connect to that. So that is the correct one for me. When you are ready to do your colorimeter readings, you are going to turn on graphical analysis and open up your sensor connection and check the ID number of your colorimeter and connect to that. So that is the correct one for me. Now for this one, we're not going to need a graph, but we do need a data table. So if you hit the box in the upper right-hand corner and just turn on the data table, you can turn off the graph, but it'll pop back up again. So either way. There we go. Okay, we're not going to do this time-based, so click on mode at the bottom, change it to event-based, and our event is just going to be the different test tubes. So you can call it test tube there, and we will have no units. When you have this in changing the mode, you want to make sure that you average your sensor reading over 10 seconds. That will give you the best data. I'm going to turn this so we can see our data table. Make sure that you are on the wavelength of 470 because that is a blue color. You might be able to see it in here, which is the opposite color of the orange that our solution is appearing. Then you're going to set up your blank. This is going to be deionized water. Remember to hold the cuvette with your fingers on the sides with the lines because the clear sides are where the light passes through. If you see smudges or droplets of water or bubbles of air, it might be a good idea to clean off the cuvette before you stick it in the colorimeter. Once your deionized water is inside and the lid is closed, you're just going to hold down the cal button and wait for the red light to stop blinking. Once it stopped blinking, then it is calibrated. We're going to take out the deionized water and then place each solution in turn. So what we're going to do then is I've placed test tube number 1 in the calorimeter, and we don't need to touch anything on, I placed it in the colorimeter. I keep saying calorimeter. So I'm going to hit collect on here, and then I'm going to hit keep, and you'll see it's averaging over 10 seconds. And then it's going to ask me to put in some sort of number. It won't let you type in any letters. So we're just going to put in 1 for test tube number 1. Tell it we're done, and to keep the point. We can see that it's giving us the transmittance, which test tube it is, and the absorbance amount in here. Now we only have 2 decimal places on our absorbance. So let's continue this process with each of the other test tubes. Be sure to write down your observations of the change in color for each of the test tubes, and remember that you can use your first test tube as your comparison. So is the color darker or lighter, more orange or red than the first test tube? And that will give us a sense of which way we're shifting in the equilibrium. Once you've recorded your observations, make sure that all of these solutions end up into the waste container specifically labeled for the iron thiocyanate. You'll need to rinse out all of your glassware to make sure there's no remaining iron to interact with the next part of the lab. And once you start that lab, you're going to want to take a little bit of the equilibrium solution, less than a milliliter, and rinse out each test tube with that so you don't add water to the equilibrium mixture. Your hot and cold water bath will be used in part 2, so don't throw away those solutions. You may need to put the beaker for the hot water back on the hot plate so that it can be hot instead of room temperature when you get to this part. For part 2, with the cobalt equilibrium, you're going to reuse your test tubes. You want to make sure that you've rinsed them several times, and you can keep your hot water bath and your cold water bath from the previous experiment. You want to clean out your beaker that you used for the reaction, but this needs to be dry, so make sure you take a paper towel and really dry it out well, or just use a clean dry beaker from your drawer. When you get to the part where you are adding things to the test tubes, the first thing that you want to do is just put a very small amount, maybe 1 milliliter in each test tube of your equilibrium mixture to rinse out any water. So kind of swirl it around and dump it out, because since water is part of the reaction, we don't want to add any additional water if we don't have to. Cobalt is mixed into ethanol, and this is to keep any of the waters of hydration from staying attached to the cobalt. We want the cobalt to be associated with the chloride, not the water. And so you'll take note of the color, and then you will add 30 drops of the deionized water. And so you'll notice there will be a color change, and of course you'll want to stir this to make sure that everything is equally distributed throughout. So this is our equilibrium mixture, and we are going to put a small amount of equilibrium mixture in each of the test tubes, spreading them throughout. You don't really need it any more than about half full. Your first test tube is going to be just your control for what the equilibrium mixture looked like. And then we are going to add a disturbance to the equilibrium system in each of the other test tubes. So you can see test tube 5 is in an ice bath, test tube 6 is in a hot water bath that they've just been put in there, and they're just starting to change colors. And then we're going to add materials to each of the other test tubes. To test tube 2, we are going to add just 1 drop of concentrated hydrochloric acid. It's important that it's concentrated because we don't want to also add water. We want to see what just the chloride does to the reaction. To test tube 3, we are going to add 3 to 4 drops of water. Then to test tube 4, we're going to add a drop of the silver nitrate. Remember that silver does not stay in solution if there are chloride ions present, so this is going to precipitate out the chloride, and so it is going to be removing one of the chemicals that is in there. So we have to think about how that might shift our equilibrium. Once we've done all of these reactions, you may need to lift up the test tubes to see how the colors have changed and make your observations based on those. And then after you have made those observations, and sometimes you might need to stir the solution a little bit to get the reaction to go completely, but do let the silver nitrate solution sit for a while so that the cloudiness can go down to the bottom.